In this video we're going to be looking at how subtraction works in a computer. So we're going to be subtracting one binary number from another essentially. Now if you haven't done lesson 4 then you're going to need to go back and do that first, because that looks at binary addition, which is vital to this part of the lesson. Before we move on to having a look at exactly how subtraction works, I want you to watch this short video which shows you all about logic and how something called an adder is used inside a computer.
You can make a circuit that adds two bits together, called an adder. This circuit takes in two individual bits, each one a 1 or a 0, and adds them together to calculate the sum. The sum can be 0 plus 0 equals 0, 0 plus 1 equals 1, or 1 plus 1 equals 2. You need two wires coming out because it can take up to two binary digits to represent the sum. Once you have a single adder for adding two bits of information, you can put together multiples of these adder circuits side by side to add together much larger numbers.
For example, here's how an 8-bit adder adds the numbers 25 and 50. Each number is represented using 8 bits, resulting in 16 different electrical signals that go into the circuit. The circuit for an 8-bit adder has lots of little adders inside of it, which together calculate the sum. Different electrical circuits can perform other simple calculations like subtraction or multiplication. In fact, all the information processing your computer does is just lots and lots of small, simple operations put together. Each individual operation done by a computer is so simple it could be done by a human, but these circuits inside computers are way faster.
Back in the day, these circuits were big and clunky, and an 8-bit adder could be as big as a fridge, and it would take minutes for them to perform a simple calculation. Today, computer circuits are microscopic in size and way faster. Well, why are smaller computers also faster?
Well, because the smaller the circuit is, the less distance the electrical signal has to go. Electricity moves at just about the speed of light, which is why modern circuits can perform billions of calculations per second.
So, whether you're playing a game, recording a video, or exploring the cosmos, everything you could possibly do with technology requires lots of information to be processed extremely quickly. Underneath all this complexity is just lots of teeny little circuits that turn binary signals into websites, videos, music, and games. These circuits can even help us decode DNA to diagnose and cure disease. So, what would you like to do with all these circuits?
Okay, so from watching that video, although it didn't talk too much about subtraction, it did talk about the fact that it's important to keep computers as small as possible. Now in order to do that, actually one of the easiest ways to subtract numbers is to add a negative number rather than subtracting a number. So that obviously is then going to mean less hardware and circuitry because we only need to use an adder. So for example, 100 minus 99 is the same as 100 plus minus 99. Now you should know that from maths, I would hope. However, trust me, it is the same. 100 minus 99 is the same as 100 plus minus 99. So therefore we can use an adder, but we're going to need to convert numbers into negatives first, which is what we did obviously in the in lesson 6. So, binary subtraction then. So it's the same as binary addition, however we convert the numbers to be subtracted into a negative binary number. So 10 minus 4 is going to be the same as 10 plus minus 4, but we're going to need to change 4 into minus 4 first. So it's kind of a two-step process. So using another example then, to take 12 away from 15, we're first going to need to take the 12 and turn it into a negative number. So step 1, write out the positive version of the number in binary first. So a nice easy one, all zeros apart from an 8 and a 4, which gives us our 12. We then have to use 2's complement to convert that into a negative number. So starting from the right, at the moment this is just our normal positive 12. As you can see, we've got an 8 and a 4. So we're going to leave all the numbers the same up to and including the first number 1. If you don't know what I'm on about, you need to go back and watch the negative numbers lesson, which was lesson 6. So we're going to leave all of those the same, which we have done here, but we're going to flip all of the other numbers so that they're now the complete opposite. So the 1 becomes a 0 and the zeros all become 1s. So now what we've got here, 1 1 1 1 0 1 0 0, is minus 12 using 2's complement. And then what we can do is we can add the numbers together, because we know that 15 plus minus 12 is the same as 15 minus 12. So along the top here we've got 15, we have our 8, a 4, a 2 and a 1, which when you add those up together gives us 15. We've then got our minus 12 down here, and we can just add them as we did in lesson 4. So 15 and 2's complement minus 12, as I've just said. So 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 1 is going to be 1 0, so we've put the 0 down there and the 1 as our carry. Exactly the same on the next one, because we've got 1 1 and a 0, so we've got our 0 there, and then we've got our carry going at the top. Another one that's exactly the same, a 0 and a carry 1, another one that's the same, another one that's the same, and we're just adding them up as normal. Anything that overflows we just ignore. Okay, so what we've now got is 3, 2 and 1. So we can check that manually, in our heads, 15 minus 12 is 3. So we can see, and we've proved that that does work. So 15 minus 12 is the same as 15 plus minus 12. Okay, so we're going to go through one more example, just doing that sort of step by step with me writing it out. If you're confident, obviously feel free to skip this bit, but you will be doing some of these in a moment using this table, so it might be useful to see how this table works even if you understand the process. So if we wanted to do the calculation 100 minus 25, we obviously know the answer is going to be 75, so we can check that in a moment. So TC, 2's complement of the second number, step 1. So the first step is of course to convert 25 to minus 25. So to start with, we need to write out 25 as normal in binary, so we don't have any 128s or those or 32s. We will need a 16 and we will need an 8, because that's taking us up to 24. That leaves us with just 1 to find, so that's there. Double check it. 1 plus 8 is 9, add on to the 16 is 25, so I'm happy that that is 25. Using 2's complement, we're then going to turn that into minus 25. So we're going to keep everything up to and including the first 1 the same. Now it happens that the first number's the 1, so we're going to keep that the same, but we're going to flip everything else so that it is its complement. It's the opposite. So 1 1 1 0 0 1 1 1 is minus 25. We've got our carry line here, which we're not going to use at the moment. We've now got a line for our first number. Our first number is 100. So we can't have 128. We can have a 64, and we can have a 32, which takes us up to 96. We've then got 4 to find, so we can't have any of those. We've got our 4 there, so we've got our zeros here. So that is 100 in binary. We've then got our second number, which we've already calculated here, so I'm going to cheat and I'm going to copy and paste that to there, so that now we can start to do our addition. So 0 plus 1 is 1, 0 plus 1 is 1, 1 plus 1 is 0, carry 1, 1 plus 2 zeros is 1, 0 plus 0 is 0, 1 plus 1 is 0, carry 1, 1 plus 1 plus 1, well, that's 3, 3 in binary is 11, so it's a 1 down here and a 1 there, that's our 11, 1 and 1. We've then got 1 plus 1, which is 0, carry 1. I'm going to put it over here, but we are going to ignore that because we ignore our carry. That then should be our answer. So if we convert that now back into decimal, we should get 75. So we have a 64 and an 8, which takes us up to 72. We have a 2, which takes us up to 74, and our 1, which takes us up to 75. Therefore, that is our correct answer, and that is how you do binary subtraction. Feel free to watch this video again if you're struggling, especially maybe this last bit where we're doing this number here. If you are struggling when you get to your OneNote to, obviously you'll be able to do this bit, which is just you writing some notes on how to convert numbers. You've got a table here that you can use, copy and paste whenever you need it. You've got an example here, 52 minus 20, and then you've got another spreadsheet. If this spreadsheet again fails to open for you, do this on paper, do it in Word, whatever you need to do, as long as you get to have a practice at this and you get to put your notes on your OneNote. Okay, once you have finished this, you've got a summary table here, which I want you to fill in to explain how happy you are with each of these sections, so I know which bits we might need to go over again. If you have any spare time, I would recommend updating and completing your Year 7 or your binary guide, which is now going to cover negative numbers and also binary subtraction. Next lesson, you will be doing an assessment on all of these mathematical conversions. So we will spend some time next lesson revising. However, if you get any spare time, it might be worth flicking over some of these videos again, just to remind you how to do all the conversions. Don't need to stress about the assessment. I know it's a bit odd working from home. However, we will be doing a short assessment just to see which bits we need to cover when we do get back to school.